The way that you turn a qualitative model into a dynamic simulation is by specifying um, constants and value formulas for the various entities that are part of the model. So I want to spend a few minutes and talk about the equations editor and functions which you use to define these pieces. So in Insight Maker, all of the there's a video, another video that talks about the structure of stock and flow diagrams. So I'm not going to go into the rules associated with constructing the diagram in this particular video. What I want to talk about is the way that you define the what's behind the scenes for each of these entities. So whenever you select an element, a stock or a variable, there is in fact a, either a constant or an equation associated with that primitive, and it shows up over here in the value/equation, which you can click here and open the dialog and edit it from that perspective, or when you mouse over it, a small equal sign pops up and you can click that to open the equation editor. Excuse me. So within this window is where it shows you the other primitives which connect to this primitive that you can in fact use in formulas. You can then develop a formula with the typical mathematical notation, or you can use the built-in functions that are provided with Insight Maker. And while there isn't an online definition of every one of these formulas, in the focus page there is a link to the SimGua manual, which is another simulation package which does in fact define all of these functions. But when you use one of the functions, when you click on it and insert it, it tells you, it shows you the form of the function and where it is that you're supposed to put the value as part of the equation editor. Now, when you build an equation, there are in fact three different ways to reference the values. The typical way that you use the majority of the time is simply the bracket notation. So and it does that by default so that when you click a variable, it puts it in brackets as part of the equation. So if I went and made this times and put revenue in here divided by pros, all right, it will include the brackets when I put the variables as part of the equation. Though, and what that means is that the current value of that particular primitive is supposed to be used at this point in the equation. The other two alternatives are if you are talking about something that where you need to reference not the current value but the entity itself, there is a less than greater than notation. This is used for delays when you actually don't want to know about the current value of that entity. You want to know about the entity itself and its value in a previous point in time, and I'll show you that in the model in just a moment. And the other type of notation is the double bracket notation. If the stock that you're referring to is, rather than a typical container, if it's a conveyor which is divided into slots, if you ask about the value of that stock, it will tell you what's in the last compartment of the stock about to leave. If you want to know what's in the sum of all of the slots in the conveyor in total, you use a double bracket notation, and I'll show you that in a model in just a moment. So in terms of this particular model, this is one that's often used to demonstrate the implications of small changes having far-reaching impacts over a period of time. And that happens because this particular stock is a regular store that simply has a value in it, and it's initiated with 60 pros at the beginning of the simulation. This stock is a conveyor with 6 slots in it, and it's meant so that that when the simulation runs, for what enters, it takes 6 time periods for what enters to come out the other end. So what moves from rookies to pros is whatever's in that last time slot when it moves to the next period. So if I want to count the number of employees, I want to know the number of pros and the total number of rookies that are in this stock. So if I look at this, it has the double notation for the rookies plus the single bracket notation for the pros. And I have to explicitly do that when I use it in a formula, because it doesn't know whether I want the single or double bracket, whether I want the current value or the sum total of what's in that element. So you simply need to know that you need to enclose it in double brackets if you want the entire value of this particular stock. So that happens here in the number of employees. If I'm figuring the rookie revenue, it's the number of total number of rookies in here times their rate, and the total number of rookies, which is also a double bracket notation. The alternative, if I'm in this situation represents a balancing loop with delay, whereby the current state is delayed being sensed at the gap based upon a delay time period that's specified by a slider. This delay state itself, if you look at the equation, it's the delay function, which is here, and the current state is in the less than greater than notation, because I don't want to know the current value of current state. I want to take that entity so that I can look this time delay back in history to find out what the value was, so that is in fact what gets communicated to the gap for the computation. So those are the two instances where the different notations are used, and once you use them a couple of times, I mean, initially they're likely to be confusing, though once you use them a couple of times, it won't be that difficult. And if you in fact use a formula that requires that the container reference, when you select it, it tells you that it wants the primitive reference, so that you know that you need the primitive reference form as opposed to the standard bracket notation form. So it's just 99% of the time you will probably use the normal bracket notation form. Once in a while, if you're dealing with delays in the structure, you'll need the less than greater than form, and if you're dealing with a conveyor, then you need the double bracket notation. So hope this has been helpful, and I'll see you in the next video.